Okay, so we're going to learn about the distributive property. We've talked a lot about the distributive property in past videos, and in this video we're going to use letters. In the last video we only used numbers. So remember, distributive property is a way to show equivalent expressions. It's a way to kind of rename an expression to make it still have equal value but definitely looks different. So we'll first start off with the parentheses and we'll split that apart so they are both multiplying but still equal to each other. So the first one, we are going to distribute the 6. Remember, there's a parentheses, and this parentheses means to multiply. So we're going to be multiplying twice since there's two numbers inside the parentheses. So the first thing we're going to do is we're going to multiply that 6 by the a, because remember that means to multiply. So that would be 6 times a, because I don't know what a is, so we just write a, okay? Next, we do the same thing. We're going to distribute that 6 now to the b, and we're still multiplying because of that parentheses. So we're going to do 6 times b now, okay? Then I can see that I'm adding, so I want to make sure that between those two I put addition. And this is distributing. So now these two are equal to each other. They just look different, but would have the same value depending on, what my A and B was if I were to then solve this expression. So we're done with that. Next, do the same thing. We're going to distribute again to find an equivalent expression. We're not solving anything. We're just making equivalent expressions. So again, we're going to take that x and we're going to be multiplying that x now by x. So just like this, we're going to do x times x. Okay, just like that. That's what that looks like, all right? Next, we're going to then take the x and we're going to multiply that by the 4. Okay, so again, that would be x times 4. This time I have a subtraction sign, so I'm going to put subtraction between the two. So these two are equivalent. Now, there's another way that we can write this to make another equivalent expression, because I can put some things together and get rid of dots. And it's really important that we try to get rid of our dots. Even in this one, we could have got rid of the dots. So like this one, we could have got rid of the dots and just said 6a plus 6b. See how I just got rid of the dots? Same thing, just no dots. Here we can do the same. So here I have an x and an x. Remember, x times x is an exponent. So that would be x squared minus, I want to get rid of my dot, but remember my coefficient needs to be in front of the variable. So then this becomes 4x. So as you can see, I just created 3 equivalent fractions for each one, just in one step, okay, using the distributive property. All right, the next one. Here we have 3x. So again, we're going to times 3 times x, and that gives me 3 times x. Okay, same thing, we're going to times that by the 9. So we're going to do 3 times 9, and then we're going to put an addition sign in between. Okay, so this one we can even simplify further after we've distributed. So again, we're going to take the dot out. So we're going to do 3x, but here remember that dot means to multiply, so we're going to do 3 times 9 is 27. So we just wrote another equivalent expression by taking it one more step. Okay, here's another one. Now this one, we're going to work from going this way. Now we're going to flip our direction, okay? So now we're going to put this into parentheses using the distributive property. So that's where we're going to go in the opposite direction. So when we go the opposite direction, this time we're looking for a common factor. So as you can see, I have a 12 and a 12. So the 12 comes outside the parentheses because the common factor always goes on the outside, and then what's left goes on the inside. So I have an n and a 6. And then don't forget we're adding, so I put an addition sign in between. So now we just kind of flipped our direction, going from this side to flip to go to the other side. Okay, this one, same thing. So we're going to pull out a common factor. So a lot of kids look at this and they're like, I don't see a common factor. There's a 5, an x, and a 25. So we have to think about this 25 and breaking it up so that there is a common factor. Remember, 5 goes into 25. So really this is 5 times 5. So I like to think of that, because then do you see you have a common factor, because it both goes into 5. So that's what we're going to pull out, is a 5. And then what's left goes in the parentheses. Since I use this common factor and this common factor, what's left is the x and the 5. So that's what goes in the parentheses, the x and the 5. And then I'm adding, so that goes between the two. So as you can see how that's 5x? And then 5 times 5 would give you back to that 25. Okay? All right, now this one again, common factor. I see that I have a 4 on both sides, so that comes out. What's left is the x and the y, so that goes inside the parentheses. And since I'm adding, that goes between the two. So I have 4x plus 4y.